Hello there, CP Finite Mathematics. Welcome to Lesson 2.2. How do you solve a system of linear equations algebraically? We're going to look at two methods. The first one is the substitution method. Hopefully, you guys remember doing some of this stuff from Algebra 1 and 2, and we'll just refresh you here. So, our first example is a system 3x plus 2y equals 2, x minus 7y equals negative 30. What I like to do usually is kind of label my equations, okay? This will be the red equation, this will be the blue equation. You can use numbers, whatever you'd like. And the idea is to solve for a variable that you can substitute for. So you may need to solve for a variable if it's not already done for you. And usually the easiest one to do is one that has a coefficient of 1. So looking at these equations, I can see that this x has a coefficient of 1, and that's just going to make it easy to solve for. So simply put, I can rewrite the blue equation as x equals 7y by adding 7 to the other side minus 30. Now that that x is solved for, I can take that from the blue equation. So I know that x is really 7y minus 30. And I can put that into x, or substitute it into the other equation, to the red one. So the new red equation is essentially 3 times the quantity 7y minus 30, because that's really what x is. Okay, it's this whole thing. And then plus 2y equals 2. So that is essentially the red equation with x in there. Now, it's just simple distributing. Okay, 21y minus 90 plus 2y equals 2. And then just solving from there. So combining our like terms, 23y equals, if I add 90 to the other side, 92. And then we'll divide by 23, divide by 23. I have my calculator here, 92 over 23 is 4. So with y equal to 4, you then just need to backtrack a little bit, and you can substitute it into any of the equations. You can put it into the blue equation, you could put it into the red equation, you could even put it into the equation we made. I am going to use this equation because then we can just solve for x pretty easily. So x times 7, replacing that y with 4 minus 30 just means that x is 28 minus 30, or x equals negative 2. So substitution method, hopefully you recall doing that in the past, and that's that there. Remember again, that would be an example of a consistent system. Okay, so substitution. Another example, one a little more challenging because we don't have a coefficient of 1, is just to solve for variables still and substitute it in. Now, this one's a little trickier because neither has a coefficient of 1, so we'll just have to work with what we have. And really, the idea is try and pick one. You have to think a little bit, what would be nice, or what will come out and not have as many fractions. So you have different choices. I'm going to solve this equation for y. So what this will look like is 1/2 y equals negative 2x. And then to get rid of the 1/2, if I multiply everything by 2, then I know that y is equal to negative 4x. So the idea is, the goal here is to make this in terms of just a 1y. Now that negative 4x, I'm going to substitute into the blue equation for y. Okay, and that would just be 3x minus 4 times negative 4x equals negative 19/2. Okay, don't be afraid of fractions. You guys are older students. You've been doing math for a while now. Fractions shouldn't scare you too much. So I have 3x plus 16x equals negative 19 halves, which makes it 19x equals negative 19 halves. And I'm going to divide by 19 and divide by 19. Now, when you do this, okay, in your calculator, make sure you have negative 19 halves in parentheses divided by 19. If you don't have that in that order, you will get the wrong answer. So make sure you put parentheses. Always put parentheses around fractions. If you did it correctly with those parentheses, you should have x equals negative 0.5, okay, which is really negative 1/2. So as you're doing these, try that in your calculator, parentheses around the fractions, okay? Now, with x equals negative 1/2, you can then substitute that in. I'll choose this equation I made because that will give me y right off the bat. So y is equal to negative 4 times our x, negative 1/2. Shouldn't need a calculator for that one, but that's okay. Negative 4 times negative 1/2 is 2. So it's always a good idea to, again, put those parentheses in there. And then you can just write your answer as coordinate point, negative 1/2, comma 2, another consistent system. Okay, so that's the substitution method. Alrighty. The next method is elimination. Elimination, you have your options as to what you should do. You can practice each, though, to get stronger. Elimination, the goal of these is to have opposite coefficients. So we're not going to solve, but we want opposite coefficients of a variable. Now that might require some multiplication. So for this equation, this system, we'll have our red and blue. I see here actually that they already are opposite. Notice here we have a negative y and we have a positive y. Okay, they're opposites one another. This is positive 1, that one's negative 1, or positive 1, negative 1. What you can then do is just add the systems together. So x minus 3x is negative 2x. Notice what happens here. 1y and negative 1y and 1y essentially eliminate. So you don't need to write anything there. It would just be 0. And that equals 3 plus 1 is 4. Don't forget to add the last column there too. Divide by negative 2. Divide by negative 2. Easy peasy. X equals negative 2. With that then, you have to substitute into either equation. You can put it in blue. You can put it in red. Really, your choice. I'm going to put it in the red equation. Negative 2 minus y equals 3. And I'll just add the 2 over. So negative y is 5, which means positive y is negative 5. So negative 2, negative 5. Elimination method for that one there. Alrighty. Hopefully, again, this stuff should be coming back to you. The next example, this one, you have a little bit more work to do. So we have our two equations. I'll label them differently this time, 1 and 2. For this time around, we have a coefficient of 2y and a negative y. So the easiest way to do this one is to multiply the top by a positive 2. Now what that's going to make is our new equation up top is going to be, and you have to distribute to everything, 4x minus 2y equals 10. Now you don't need to do anything on the bottom. You might need to in the future, but in this particular case you don't have to. 5x plus 2y equals 8. And this right here, I don't know why I got all fancy with my voice, that's what you want, opposite coefficients. So those are going to eliminate. 4 and 5 is just 9x, and then equals 18. Divide by 9, divide by 9, and x again equals 2. Hopefully you're getting the hang of this. Now just substitute back into equation 1 or 2. I'll use equation 1. So it's 2 times 2 minus y equals 5. 4 minus y equals 5. Subtract the 4. Negative y equals 1, which means positive y equals negative 1. So we have 2, negative 1. Okay? You might need to multiply both equations. Okay? And you know that you can just do that. Again, the goal is just to have that opposite coefficient going on there. Okay. Moving on. So again, should be reviewed. Let's just see what some of our special cases look like. So inconsistent. You remember what that means? That means no solutions. What will occur if you have a no solution example? So let's say you come across this problem here. You want to use elimination. We can do that by multiplying the top by 2. And that will result in a new equation, negative 2x plus 2y equals negative 14. Now let's notice what happens. So if I'm adding together, we'll say that's red, blue, and this is really still red, it's just the new red. If we add together these equations, whoa, our x's cancel, our y's cancel, and we end up with negative 22. Now, really what's here is that 0, nothing, equals negative 22. Well, last time I checked, 0 and negative 22 are not equal. And if you end up with a situation like this, that means there is no solution, and you should classify it as inconsistent. To clarify, if you have something like 5 equals negative 4 or 3 equals 20, okay, all of those are examples that would lead to an inconsistent system. So it doesn't just have to be 0. That's what will usually happen with elimination. Okay. On the flip side, we have a dependent or infinite system solution, infinite solution system. And what that will look like, let's use substitution method on this one. Why not? Again, you can use either one you'd like. So I'm going to rewrite y equals negative 2x plus 4. Substitute that in for y, negative 6x minus 3 times negative 2x plus 4 equals 12. And you'll notice here we would have negative 6x plus 6x minus 4 equals, sorry, that should be a negative 12. Negative 12. And wow, I'm messing up all over the place. Make sure you distribute. Don't lose that. Negative 12. And notice here, the 6 and the negative 6 cancel. And this time we end up with a statement that is always true. Negative 12 is negative 12. So if you end up with a true expression like that, then it is infinite solutions. Also, dependent system. Okay, so be aware of that. The two different scenarios, students will mix those two up, infinite or no solutions. And again, be careful with your distributing, as I did myself, and that's really the idea. So that's the first part, okay, pretty brief. I'm going to jump into applications. Make sure you have those down. If you want to pause and practice, go for it, and you can come back and learn the applications. The applications of two variable systems, word problems, everybody's favorite. They're really not bad. The hardest part is setting them up. Okay? Coral Movie Theater charges $9 for adults, $7 for seniors. On a day when 325 people paid admission, total receipts were $2,495. For all these problems, you're going to need two equations. Okay? And the hardest part, again, I think, is deciding what is in each. So let's look at our first. It's always a good idea to look at what are we trying to find. We are trying to find the number of adults and the number of seniors. So by looking at what you're trying to find first, you can let that be your variables. We'll let A be adult and S be seniors. So when we look back through now, we can start to put our words into equations. Now, you want to try and keep units in the same equation. So let's look first at the money. So $9 for adults. So that's $9 per each adult. $7 plus seniors. If I add the number of seniors that come, I know that I should end up with, how much money did they make? $2,495. So all the monetary values are included. Now the other one, the only other bit we have is that 325 people attended. Now we're only considering adults and seniors. Yes, children and such might have come. But what we know is that the number of adults plus the number of seniors must be equal to 325. Okay, so the second equation deals with the number of things. And this is just one particular example. Now, once you have those equations, it's really just those methods from above, substitution or elimination. I would choose substitution. Again, you might do differently. And I'm going to solve for A. I know that A is negative S plus 325. With that, I can substitute into A in the money equation. So then, what that would look like is 9 times negative S plus 325 plus 7S equals 2,495. So I'm distributing negative 9S. I'm going to use my calculator here. 9 times 325 is 2925. Add another S, and that's equal to 2,495. Boop, 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 boop. Just rewrite some things. So negative 2S is equal to, just going to do it all in one step here, 2,495 minus 2,925, negative 430. And your answer should make sense. So I know sometimes students panic when they get that negative, but we do end up with a positive because negative divided by a negative is a positive, which means that 215 is equal to S. Now, we just need to find the number of adults. So again, any equation that you've worked with, you could use. This one, this one, this one. I'm going to use the adults is equal to negative 215 plus 325. And really it's 325 minus 215. And the adults then is 110. Word problems, please be specific and include units. So what this means is the number of adults is or was 110, and the number of seniors was 215. Let's forgot to include adults there. Something like that is what I would like you to express your answer like. Okay? Again, setting up the equations is the challenge. Definitely practice these when it comes to it. Our last type of example is something little, there's not many words here, but we can still figure it out. Perimeter of a rectangular floor is 90 feet. Dimensions of the floor, find the dimensions of the floor if the length is twice the width. I always encourage, draw a picture, okay? What do we have? We have a floor here. Nothing too exciting. Now, within these questions, when you see things like perimeter or area, always think, okay, that means somewhere along the line, I'm going to need to use the perimeter formula. Perimeter is 2 times length plus 2 times the width. Okay? Now, with our picture, we can kind of work with what the dimensions would look like. Length is twice the width. So if this is the width, I know that this distance, I know it's not drawn to scale, must be 2w. So length is equal to 2 times the width. With those then, we can start plugging things in. So first off, perimeter, 90 feet. Well, that means P must be 90. 2 times the length. Well, length is really, we're going to use substitution here, 2w. Okay? And then plus another 2w. From there then, it's just 90 is equal to 4w plus 2w, or 90 is equal to 6w, and we'll divide by 6 to find the width. And 90 divided by 6 is 15. And that just means the length is 2 times the width. So length is 2 times 15, or length equals 30. Now the dimensions, so the final answer then is 15 feet by 30 feet. So just to specify, clarify, these were our 2 equations, perimeter and length, and that's how it became a system. We essentially use the substitution method. So with dimensional problems like that, draw a picture. It can be helpful. With other problems, just try and figure out what goes into what equation. Okay? So practice will be listed on Schoology for this, but great job, guys. Those are 2.2 notes.